you very much, Christina. My name is Abror, and I work for German Research Center for Geosciences. And today I will be talking about the climate change impacts on hydrology in Central Asia. And I'm really happy to be part of such a discussion, because this is exactly what we should discuss in the future or currently, in order to be prepared for climate change, which is happening in the region. So yes, the water formation in Central Asia, we all know that we have this wonderful region where water resources are formed in the mountains, and these mountains also play a role of natural water reservoirs, where winter precipitation falls as snow, and we also have glaciers where long-term water resources are stored. And during the summer months, we have a melt of this cryosphere, which feeds the rivers, which is then used highly for irrigation downstream. And if you see this map, we have this glacier distribution in the region. We have like more glaciers in the Pamir than in Tian Shan, and we also have irrigated areas in the region where water resources are used in summer months. And as you know, agricultural production is a key factor for economic stability in the region. So we are living currently in a situation we have at the moment. So in the mountains, there is in winter snow accumulation, glaciers up there, and in summer we expect some water, and with that we produce energy, agricultural production, and we live for that. But we are not sure that this will stay longer. We should be prepared for any kind of changes, reduction of discharge or water availability in the future, for example. And if we look this typical hydrological regime in Central Asia, in the example of the Rafshan Basin, we see that this orange color is the temperature. Okay, of course, in summer we have higher temperatures. We have a precipitation mainly in spring and in fall, with marginal precipitation amount in summer months. But if we look the green color, that is the discharge, which is the highest in summer months. This means that they are mainly fed from glacier and snowmelt conditions. And therefore, we can subdivide our hydrological components into different parts. Like in the beginning of the year, we get the water from baseflow and from rain-fed water. And in the spring months, we have a high concentration or a high component of snowmelt. And in the late summer, we have a glacier melt, and then again baseflow and rainfall. And now imagine if we have a temperature increase, let's say, and we expect with temperature increase the degradation of glaciers. This means that we expect the decrease of this amount, which would then have an impact on water availability in these months, which is highly important for agricultural production. So yeah, now let's see the climate change records that we observed in the last years. When we see such a map, which is an example for Nile Station, we see there is a kind of trend. And we can say, okay, there is approximately 1.5 degrees of trend for the last 60, 70 years. But we also see from this figure that this trend is not always the same. There are periods where trend is where the slope is higher, and then we have kind of a break, and then we have again a trend. So we should not consider the complete temporal frame into consideration, but we should also consider the different temporal windows. And this is only one station, but we should also not consider that the information we are getting from one point, from one station, is applicable for whole region. So we should consider different stations. And this is what is shown in this figure. This, I put only summer temperature trends in Central Asia for different stations. Here the station names like Chimbai, Narin, Tianshan, Toktogul. And then we have here in this axis the years of beginning years for the trend analysis. And this is the end year for trend analysis. So this would mean that from 1940 to 1970, 30 years trend for all of these stations, and then the next 30 years, the next 30 years. When we see such an image, we see that climate change is there. It cannot be neglected. But we also see that it is changing temporarily. So there are, for example, these red points where the climate change is enhanced. But there are also some periods where it is yellow or green, where climate change is taking like a break or is not that much enhanced in those locations. So yeah, and these these points mean that they are statistically significant at 95% confidence level, which is important in analyzing the temperature change in Central Asia. So if we have this temperature change, we can see what is the impact on glacier degradation. For that, we have taken the Landsat images for 3 time spans, and we compared what is the area reduction in these 3 time frames, and we came up with the result of 23% for the Naren Basin at the highest. But it's also regionally different inside the Naren Basin. But this 23% of glacier degradation is already a high number, and we should handle this information with carefully when we develop adaptation strategies for the region with regard to water availability in summer months. We have also taken satellite-based snow cover data, and we also analyzed the changes there. And this figure shows for different river basins the changes in different months and also in different seasons, and then overall for a year. And the trend here, the legend shows if it's more blue, then it's more snow. If it's more yellowish, then it's less snow happening in the future or in the past years, the trend. And when we look the overall picture, we see that we have more yellow colors than green colors, meaning that snow cover is also decreasing, which would have an impact on water availability in the future. So then we can see the past records on discharge. This is one example I just plotted fast yesterday, where we have, for example, monthly discharge observations for the small Naren Basin. It's a mountainous basin, and we see for different months, January, February, March, etc. And we see from these figures that in the beginning of the year or in the first half of the year, the discharge is increasing, which may trigger the flash floods or other events. And then we have such a month where it is more stable, and but we see when we consider the July and August months, we see the decrease of discharge, which can be connected to degradation of glaciers, which mainly contribute to water resources in these months. So that was the past records. What's the future? What will be in the future? And there have been some presentations already shown with regard to climate projections in the region. And yeah, we have also took this data for Naren, Karadarya, and Zarafshan basins. Naren and Karadarya are located in Kyrgyzstan, and Zarafshan is located in Tajikistan. And these dashed lines show the temperature increase in individual basins. The red color is for Zarafshan, the green color is for Karadarya, and the blue color for Naren. And the continuous lines show the precipitation. And from this figure, we see the temperature, okay, it will be increasing in the future, but when we come to precipitation, we are not sure. We don't know what will happen, because the climate simulation does not show a clear picture on that. So, yeah, and in this image, only one realization is considered. And you can ask, okay, how can you believe on one climate model when it simulates the future projections? And to overcome this uncertainty, we use the all available climate models simulating the IPCC simplified projections, and they are about 30 for the region. And we did like climate change analysis in the Tian Shan and Pamir mountains. And from these figures, we see that, like qualitatively analyzing the figure, we can say that in the Tian Shan, the temperature increase is more enhanced compared to Pamir mountains. But when we come to precipitation, again, we are not sure. There is no clear change or trend visible. But we can also see that the variability of precipitation is higher, so the uncertainties related to precipitation is higher in both mountain basins. So the question is that what will be the impact of this change on water availability in the future? For that, we have taken the hydrological model, a semi-distributed hydrological model, VASA, and there we included the dynamical glacier evolution approach. I hope some people understand this approach. And we also used multi-objective calibration, where we use glacier mass balance, satellite snow cover data, and the discharge to constrain the parameters of hydrological model, to estimate the components correctly and also project the components correctly for the future. And yeah, these are the 3 basins where we tested that, and our results show glacier decrease in Central Asia in all 3 basins with different intensities again. So in the Karadaria Basin, the results show that glaciers are almost disappearing. In the Naren and Zarafshan basins, it is a bit different, but the intensity in the Naren Basin is higher than the intensity in the Zarafshan Basin. But when we consider these simulations, we also see that by the end of the century, there will be a significant less glacier area available in the region. And when we consider these changes also in the discharge, then we can see that the discharge will be shifted towards...
Excuse me, you have 1 minute.
Okay, that's the last slide. Here we have in green the control period. So that's the current situation, and these are the future projections. And if you see the future projections, we will have less water availability in summer months, which is very important for agriculture production, and we need to be prepared for that. But we also see the increase of discharge in spring months, which may trigger flash floods in the region. So the conclusion, the climate change in Central Asia is fact. We cannot neglect it. We have observed this, and changing climate will have an impact on water availability. We have also seen this in one example, and I showed only one example, but I would say that this is one drop in the sea, and we should increase number of scientific questions, or as Christina said, build relations between the groups where we do climate impact assessments. And adaptation strategies for new conditions under climate change impact needs to be prepared. Yesterday I was talking to someone who said to me, we do science and we publish it, and when we publish it, we shouldn't expect the implication directly after that. We will need about 10-15 years until the published results will reach the farm level or the population. And therefore, I think we should not wait here longer and be prepared for future changes. So with that, I thank you very much for your attention.